Good evening, ladies and gentlemen. I want to make sure that last part we did in class, I know I rushed through it, so I want to make sure that I at least show you examples of two more, just so we understand what to do. So here's what I'll do. Since you guys have to do some of these odd problems right here, what I'll do is 24 and 28. So you guys have examples of radian measure and degree measure of what exactly to do. So let me zoom in a little bit and grab that. Let's do these two. All right, I'll take it and I'll put it in. Uh-oh. There we go. Let me do secant 135 first. Now, first off, if we're doing, well, let me change my, say we're doing number 24. If I'm trying to do secant 135, first off, I want to see where the angle goes. Let me take up that many lines. So trying to do this right here, I'm going to try and get a, don't laugh at my circle, but actually, hold on. This is an actual better graph to do it on. So let's work with this graph. Now, if I'm doing secant 135, trying to do secant 135, then starting from the initial side, remember that this is that's x, but for better purposes, you can say that this right here is just 0 degrees. This is 90. This is 180. And this is 270. And also, this is 360. So we can say that. So basically, if I'm trying to get to 135, if I start at the initial part, my angle is going to go all the way to the second quadrant and stop probably right around there. Please forgive my writing. The computer's in an awkward position right now. So that means that it's going to be an angle that kind of looks that way. So let's say this is a 135 degree angle. Now, since that's a 135 degree angle and I'm looking for the secant, I first need to find the reference angle. So I need to know what this angle is. Now, the reference angle, we can easily find the reference angle by doing 180 minus 135. And if I do that, I'll know that the reference angle is actually going to be 45 degrees. So what that means is that secant 135 is very similar to secant 45 degrees. However, remember that secant is the opposite of, in other words, secant equals 1 over cosine. So since that's the case, remember that all students take calculus. So since all students take calculus, then only sine is positive in the second quadrant, meaning that cosine is negative. So that means that secant 135 is very similar to negative secant 135. I mean secant 45. So now we can actually do more with that and say that's equal to negative 1 over cosine 45. Now, how we find out what cosine 45 is you just get the 45-45 right triangle. Now, keep in mind, it's 45 degrees here, 45 degrees here, and this is a 90-degree angle. And the measurements of the sides are 1, 1, square root of 2. So since those are all my measurements, cosine of 45, if I take any 45-degree angle, cosine of that is adjacent over hypotenuse. So you're talking about, in this case right here, you mean negative 1 over, since that's the case, remember cosine 45 is equal to 1 over the square root of 2. So in this case, it's negative 1 over the square root of 2, which is just negative 1 over the square root of 2, which is just negative square root of 2. So that's how we actually evaluate that trig function. It's a little bit of work, but hopefully if you have any issues with it, you can always contact me. Let me actually do the other one now. So we just did 24. Let's do 28 now. If we're trying to find cosine 7 pi over 4, first let's get some axes and find out where that actual problem is. With these axes right here, I can actually go, if I'm talking about 7 pi over 4, remember that this is 0. There's two ways you can attack this. Remember, this is 0, pi over 2, pi, 3 pi over 2, and this is the same thing as 2 pi. So we're trying to figure out where that actually is. The two ways you can figure this out is since 4 goes into 7 one time, that means that your angle is making at least one full revolution around. However, when it does make that, actually, hold on one second. I don't want to mess this. Actually, the correction to that is since you have 7 pi over 4, you're not really at 2 pi, because in this case right here, 2 pi would equal 8 pi over 4. So since we're at 7 pi over 4, we're not really 2 revolutions around, but we are very, very close. So meaning that if we go all the way around, it should be probably relatively like right here or so. And the reason why is because how far are you away from 2 pi? If you're at 7 pi over 4, then to get to 2 pi, in other words 8 pi over 4, you're just adding another pi over 4. So what that means is that if this angle, well, let me go back. If this angle right here is 7 pi over 4, then that means that your reference angle, this angle right here, is going to be how much more you need to go to get to 2 pi. And in this case, it will be pi over 4. So that would be your reference angle in this case. So really what you're trying to find out, the same way you're trying to do cosine 7 pi over 4, that actually equals whatever cosine pi over 4 is. So that's one way to look at it. And since all students take calculus, cosine's positive in here, so we have a good match. That's one way to look at it. Another way to look at it is just convert 7 pi over 4. If you're trying to convert 7 pi over 4, remember that you are multiplying 180 over pi. Let's see, these cross out. This becomes a 45. The pi's cross out. So you're doing 7 times 45. 7 times 45 is 315 degrees. So the same way you're doing cosine 7 pi over 4, just do cosine 315 degrees. Now here's the thing. That means that this angle right here is still 315 degrees. So that means your reference angle, in other words, the angle between the terminal side and the closest x-axis, is also going to be whatever it takes to get to 360. So that means this is going to be, let me make sure I can write it, 45 degrees. So the same way you're trying to do cosine pi over 4, cosine pi over 4 just so happens to also be cosine 45. Now remember, when we're trying to find cosine 45, let me go back to the triangle here. If we're trying to find cosine 45, if this is the 45 degree angle right here, cosine is adjacent over hypotenuse. In other words, 1 over the square root of 2. So that means that this is going to equal 1 over the square root of 2. But remember, you have to rationalize your denominator. So that means each one of these, you're multiplying by the square root of 2. And whatever you do to the bottom, you have to do to the top. So you should end up with the square root of 2 over 2. So that's how you can actually calculate that one as well. So I hope that doing these two problems help you out with the other problems. If you have any issues, please contact me.